of NaOH in water would result in a decrease in a decrease in free energy of the solution, B, a decrease in the entropy of the solution, and C, a lowering of the temperature of the solution, finally D, an increase in the entropy of the solution. So in this question now, what we pretty much have is NaOH plus water. Okay, let's make that nice. That's more of H2. What we're pretty much going to have would be sodium ions and hydroxide ions that's dissolved in the solution. So right, comparing the options now, we can see that option B and D seems to be opposites of each other. In majority of the case, it pretty much means one of them is the correct option. So, and it can be C again because this reaction is an exothermic reaction. So rather than lowering of the temperature, what actually happens is increase in temperature. So automatically we know it's definitely not option C. And by method of elimination, we know it can either be B or D. So that brings us to entropy. What exactly is entropy? Entropy means, entropy refers to the degree of disorderliness of the system, disorderliness or randomness. So we know it's dissolving some pellets, so this means that it was in its solid state. So from solid to ion or aqueous state, we know from properties of solid now that the molecules of solid are closely packed, and the only thing that can happen is pretty much just vibrations. However, in their ionic form and aqueous form, they are able to move about. So that pretty much means that the entropy of an ion, or compound in its aqueous state is greater than entropy of a solid. So this means that it can be option B, and since it's not option B, it's definitely going to be option D, and that's the correct option. So moving on, question 32 says the alkanol derived from the production of soap is A, ethanol, B, glycerol, C, methanol, and D, propanol. Generally in chemistry, the production of soap happens through a process known as supplementation. Generally, the scheme of reaction is given as fat and oil, or fats or oil, plus your alkanol, NaOH, your alkaline, that's your base, to give you your fat and oil react with the base to give you glycerol, and either in this case, since we use sodium hydroxide, we give you a sodium soap. The key word here now is glycerol. We know that the alkanol react is what glycerol, so it's not option A or C or D. Correct option is option B. Moving forward, question 33. Bleaching powder deteriorates on exposure to air because A, it loses its water of crystallization, B, atmospheric nitrogen displaces chlorine from it, C, carbon dioxide from the atmosphere displaces chlorine from it, and D, bleaching agents should be stored in solution. So generally in a bleaching powder like this, we have two types of bleach basically. Bleach that contains chlorine and those that do not contain chlorine. In this case now, calcium CaCO2 plus H2, I tell that it contains what? It's a chlorine type of bleach. And chlorine is actually a key element in this kind of bleach. So we just go through the options and look at that which has to do away with removing chlorine. So it's not option D, neither is it option A. So we are left with option B and option C. Between these two, it's only carbon dioxide that is capable of displacing chlorine. So the moment chlorine is out of the equation, the bleaching powder pretty much loses its power. So the correct option is option C. Moving forward, question 34. The carbon in ethene are A, sp3 hybridized, B, sp hybridized, and C, sp2 hybridized, and D are not hybridized. Basically, hybridization deals with mixing of orbitals. So if we have sp3, it means one s orbital and 3p orbitals. What this pretty much means now is whenever elements come together to form bonds and all, there is mixing of orbitals. So in this case now, we have one s and 3p. In case of sp2, we have one s and 2p orbitals. So generally, the shortcut that I use whenever I see something like this is to just know that sp3 refers to single bonds, sp2 refers to double bonds, sp refers to triple bonds. So again, hybridization pretty much determines how the type of bond that is being formed in a compound. Yeah. So in this case now, it's pretty much saying the carbon in ethene. Ethene is an alkene. Alkene are known for their double bonds. And the structure of ethene is actually given as C double bond C H. So the question is asking the carbon in ethene, what kind of hybridization do they have? So the fact that there is a double bond, it pretty much means that they are sp2 hybridized, that's 1s and 2p orbitals. So the correct option is option C.